discussing questions on quantum mechanics, and these are questions from Zettili. Okay, so just give me a second. Okay, so here we'll be solving questions from quantum mechanics, that is postulates of quantum mechanics. Okay. And this is the third chapter. Alright. So chapter number 3. Chapter 3 in quantum mechanics. Alright. So I'll be writing the questions here. Just give me a second. Okay. So first question I will write, that is exercise 3.27. Okay. So here consider a system whose initial state at t is equal to 0 is given in terms of a complete and orthonormal set of 4 vectors. Orthonormal set of 4 vectors phi 1, phi 2, ket phi 1, ket phi 2, ket phi 3, ket phi 4 as follows. So psi 0 is equal to a by root 12 phi 1 plus 1 by root 6 phi 2 plus 2 by root 12 phi 3 plus 1 by 2 phi 4. Okay. So what is the question? A is a constant. What is the question? Find A so that psi 0 is normalized. Psi 0 is normalized. Okay. Write down the state of the system. Write down the state of the system. Write down the state of the system psi t at any later time t and any later time t if E1, E2, E3, E4 are the energies. Okay, are the energies corresponding to phi 1, phi 2, phi 3 and all. Okay, and last question is determine the probability of finding the system at a time t in the state phi 2. Okay, this is a question. Let's try this question. try this question. Okay, so how to solve it? Okay, it's very easy question. We have done this kind of question before. You see, so psi 0 is equal to a by root 12. This. So we'll just take the square of it all and add them and equate it to 1, so that in that process we will be able to calculate your a, right? So that be a square by 12 plus solution a square by 12 plus 1 by 6 plus 4 by 12 plus 1 by 4 is equal to 1. Okay, so that will be a square by okay, if you take the LCM 12, a square plus 2 plus 3 plus 3, sorry, plus 4 plus 3 is equal to 1, right? So a square plus, this is 6 plus 9, this goes to this side 12. So a is equal to root 3. Okay, a is equal to root 3. So now I can write the normalized form of this. I will just write a is equal to root 3. Okay, what is the next question in it? Write down the state of the system at psi t. Okay, how do we write psi t? Psi t will be what? Root 3 by root 12 phi 1 e to the power minus I e1 t by h cut. This is the way we write it. Okay, plus again what was the second term? 1 by root 6 phi 2 e to the power minus I e2 t by h cut plus 2 by root 12 phi 3 e to the power minus I e3 t by h cut plus 1 by 2 phi 4 e to the power minus e4 t by h cut. Okay, is that clear? Is that clear to everyone? Okay, so this is your state psi t after a time t, right? So what is the next question? Determine the probability of finding the system at a time t in the state phi 2. Okay, probability we have to find. So probability is simply what? Probability is simply the square of the coefficient of that state. So for phi 2 the coefficient is 1 by root 6, so its square will be 1 by 6. So the probability of getting phi 2 will be what? 1 by 6. Okay, this is just cn square. That means the coefficient of that straight square. Okay, okay, so this is this question. Let me know if you have any doubts here. next question, exercise 3.26. Question is calculate dx by dt dpx by dt dh by dt for a particle with h is equal to px square by 2m plus half m omega square x square plus v naught x cube. Okay, calculate this and this. Where Hamiltonian is this much. Let's try. Okay, so how to solve it? We have to calculate dx by dt, dpx by dt, dh by dt and all. Okay. So h is given, your Hamiltonian is given, right? So we'll be able to do this if we recall the equation for time evolution of expectation values. Okay, we have to recall what? Time evolution of expectation values for some observable A. Okay, so how do we do it? D by dt of operator A, observable A, is equal to 1 by IH cut. If you remember the formula, expectation value of commutation of AH, okay, plus expectation value of del A by del T. Okay, del A by del T. So the commutator between two operators we know is what? Suppose A and B commutation. So it will be what? AB minus BA. Right. AB minus BA. Okay. Right. So AB minus B, right? So if we, okay, do you remember the uncertainty relation del x del px is greater than equal to h cut by 2. Okay, and if we also write it, it can be like this, IH cut, right? So this is because why? Because the uncertainties of measurement and commutating relations are connected by what? Connected by del A into del B is greater than equal to half mod average value of AB. Okay, it's very important. No single operator has a non-zero commutator with itself. Okay, like it should be 0. So we know that AA is what? Always 0. And we can also say that AB can be equal to minus of BA, right? Minus of BA. Okay, so now if you see, this is for what? I just told you some theory. Okay, this is just theory pertaining to this question. So dA by dt is equal to this much, we know, of some observable. Here what is given? Here we are asked of x, right? So we will do dx by dt. So d by dt of observable x, just in place of a we will put x, right? So 1 by IH cut, what is there? By IH cut, expectation value x h and plus del x by del t. Okay, del x by del t. Is it clear? Okay. Now, since the position operator x does not depend on time explicitly, okay, x does not depend on time explicitly. Okay, so what will happen? Del x by del t, okay, that expectation value will be 0. So this term becomes 0. So the only this one is left. So d by dt of observable x is equal to 1 by I h cut, okay, expectation value of x h commutation. Is it alright? Okay. Now, if you see, so I can write the Hamiltonian here. The Hamiltonian is given. Hamiltonian is given. So let's write that there. So 1 by I h cut expectation value x comma px square by m 2m plus 1 by 2 m omega square x square plus v naught x cube. Okay, so if I will take 1 by 1, see the expectation value of this with this will be 0, of this with this will be 0, so only with this we will take, right? So 1 by I h cut and 2m also will go out. Expectation value x px square, okay, px square. So how will we do it? If you see a b c commutation, b go to left side, c goes to right side, so b ac plus a b and c, okay, so that will become 1 by 2 I h cut m, and this will be px x px plus x px and px. Okay, so 1 by 2 I h cut m, this is px, this is I h cut plus this is I h cut px. So this is the same thing, so I can write it as 2 I h cut, right? So 1 by 2 I h cut m into 2 I h cut px. Is it correct? Is it alright? Yeah, but yeah, this thing will be there. So 2 I h cut will come out, so 2 I h cut goes out and 2 I h cut m, and this is your px. Okay, so average value of px. So 2 h cut was cancel out, so I can write it as px divided by m, right? So what was in the left side? D by dt of x, right? So d by dt of observable x is equal to px by m. Is it alright? Is it clear? Okay, it's very conceptual. I hope you understood. I hope you understood. Any doubts, please let me know. Is there any doubt, please let me know. Okay, then should we move on to the next question? Should I move on to the next question? Okay, I will move on to the next question. Next question, not like is there like dpx by dt. You please try dpx by dt exactly the same way you have to do. Okay, d by dt of px exactly the same way you have to do. Okay, please try. Please try. Please try the same way, that is, this will be done in the same way, like 1 by IH cut Px H plus del Px by del T. See, if you see, like position operator, momentum operator also does not depend explicitly on time. Okay, you can write a point like position operator, momentum operator also doesn't depend explicitly on time. Okay, so we can write it as del Px by del T is equal to 0, right? We can write that. Okay, del Px by del T we can write as 0. Okay, so we will rewrite the equation. Dpx by d by dt of Px would be equal to 1 by IH cut expectation value Px comma H. Okay, yeah. Now again you have the H value, right? You have the H value. Please put it there. Please put it and try it. Otherwise I will definitely do it, but you please try. Put the H value there. 1 by IH cut Px comma just put the that value, H value, Px square by 2m plus half m omega square x square plus v naught x cube. Okay. See, if you see, this commutation will be 0 because same things are there. So only we will see this and this, right? So please try. Okay, this will be 0. So 1 by IH cut Px commutation will be done with half m omega square x square and plus Px commutation will be done with v naught x cube. Okay, yeah. So I will take these things out, the unnecessary things I will take out, into half m omega square Px x square, this is 1, plus 1 by IH cut. If I open the bracket, suppose this is a bracket. Okay, 1 by IH cut, this will go out v naught and too many brackets are there, Px x cube. Okay, now try how to calculate this one. See, we had calculated x Px square, which was your 2IH cut what? 2IH cut Ps, right? 2IH cut Px. So can you guess from here what will be your what? The one we need it here. What will be your Px comma x square? It will be minus 2IH cut if you calculate it and x. Okay, just see the order change is there, and like the one that is squared, that will be outside. Okay, otherwise I will do it for you. Px x square. Okay, so I can write it as Px x, right? This will go to left side, this will go to right side, so x Px x plus Px x. Now what is the commutation for this? We know commutation of x Px is IH cut. right? So commutation of this one will be minus I h cut. So x minus I h cut plus minus I h cut x. Okay, so this will be your minus 2 I h cut x, right? Okay, so just put it here, minus 2 I h cut. So this is your m omega square by 2 I h cut. This is your minus 2 I h cut x, right? Plus v naught by I h cut. And what will be this one? Just take the derivative and take the minus. Okay, minus 3 I h cut x square. Okay, how it is done? How? See, some commutator a to the power n b, otherwise don't leave it, x to the power n px. Okay, commutation will be what n x to the power n minus 1 into I h cut, right? And sorry, n x to the power n minus 1, yeah, n x to the power n minus 1 I h cut. Okay, so exactly here, but here the order is different, pxx, so there is a minus sign. Okay, so this is it here, and 2 I h cut cancelled out, I h cut cancelled out. So if you see, this will be minus m omega square x, this is a minus 3 b naught x square. Okay, so this is your what? This is your d by dt of px. Okay, is it clear? Is it clear? Yeah, another thing, this bracket is also there, no? So this bracket will also be there. Okay, is it clear? Is it clear? Should I move to the next question? Should I move to the next question? Okay, I'll move to the next question. That is dh by dt. Okay, this one you please try. This one you please try to solve. Dh by dt. I have done two now. I did tx by dt, dpx by dt. So dh by dt you please try. Dh by dt. D by dt of h. Right? See here again, 1 by IH cut, expectation value of computation of HH, this is the easiest one, plus del H by del T, isn't it? Now tell me, see, Hamiltonian in our case is explicitly time independent. Okay, there is no time t on the right hand side of the equation. If you see of Hamiltonian, you just see, check, there will be no time term. Where is the Hamiltonian? See, there is no time term in the right side of Hamiltonian. That means Hamiltonian is explicitly independent of time. Okay, explicitly independent of time. That means del H by del T can be taken as 0, right? 0. So just take it 0. So del H by del T is 0, and commutation of anything with itself is 0. So this is 0 plus 0, that is 0. So d by dt of h is 0. Okay, is it clear? Is it clear? Okay, next question. Let's do the next question. Exercise 3.23. Okay, consider a system whose Hamiltonian is epsilon 0 minus I 0, where epsilon is a real constant, with the dimensions of energy, of energy. Okay, first question is find the eigenenergies. That is your E1 and E2 of Hamiltonian H. Option B. If the system is initially that is at t is equal to 0 in the state psi 0 is equal to 1 0. Find the probability so that a measurement of energy at t is equal to 0 yields. Okay, yields E1, second bit is E. Okay, let's try. Let's try this question. Yeah, there is C also. No, more questions are there on this. Find the average value of the energy, H, and the energy uncertainty H square minus H square. Okay, and D, find the state psi t. Okay, psi t. Please try. Let's try this question. Okay, see. See, here we are given the Hamiltonian, that is H is equal to epsilon naught 0, sorry, epsilon 0 minus I 0. So we want to find eigenenergies E1 and E2 to know what are the probabilities to measure these energy. Okay. So in order to solve this problem, we follow the well-known procedure. Okay. We have that what H minus lambda I is equal to 0. No? So we can do that. So epsilon will be outside. 0 minus lambda minus I this is 0 minus lambda is equal to 0. No? So if you see minus lambda square minus this is plus I square is equal to 0. So lambda square minus 1 is equal to 0. So lambda is equal to plus or minus 1. Right. So two eigenvalues plus or minus 1 and epsilon is outside. So epsilon into 1 and epsilon into minus 1. So two eigenvalues are epsilon and minus epsilon. Okay. Now to answer what probability, what is the next question? System is initially in state this. Find the probability so that a measurement of energy at T yields E1 and E2. Okay. So again this is very good question. Option B. To answer what probability would it have, we have to find the eigenvectors for each state. So 0 minus I 0 xy is equal to 1 into xy, because 1 is one eigenvalue, so we have to find two eigenvectors, right? We have to two eigenvectors. So if you see this minus ix, okay, sorry, minus iy is equal to x, and I into x is equal to y. Okay. So our eigenvector is what? First eigenvector I will write h1 is equal to what? What will I write? X. First one is your x. Second one is your what? Second one I will write ix. Okay. Isn't it? Y. X is your x. X I will write. And y will be your ix. Right. I cannot just write minus iy and this ix. No point. Okay. So this one, this is x, this is ix. So to satisfy the this one, I can write like this also 1i. So we need to normalize it. How will I normalize it? Again, simple. h1 is equal to 1. So if you do it, it will be x square plus x square, okay, is equal to 1. So 2x square is equal to 1, and x will be what? Plus or minus root 2, 1 by root 2. So your normalization is plus or minus 1 by 2. So our vector will be plus or minus 1 by root 2, 1i, right? Isn't it? Okay, this is one vector. Another vector we can have from the eigenvalue lambda is equal to minus 1. So we do it again. 0 minus I is 0, xy is equal to minus 1 xy. Again do the same thing. So if you do the same thing, minus ix is equal to minus y, minus iy, minus iy is equal to minus x, and ix is equal to sorry, did I do the mistake? Ix is equal to minus y. Okay. So again, if you see, the eigenvector will be h2. First one is x. What is the second one? Y. Y is what? This goes to this, so minus x, minus ix. Okay. So again, we have to take this one, 1 minus I. So normalization factor will be again 1 by root 2. Okay. So 1 by root 2, 1 minus I. Same thing. 1 root 1 minus I. So this is your energy first state. This is the first one. This is the second one. Okay. What is the probability of find the first one? We know probability is just simply what? simply your coefficient square. So coefficient was 1 by root, so 1 by root 2 square, that is 1 by 2. Again now, probability of getting 2 state, second energy state, that is C2 square, that is 1 by root 2 whole square, that is 1 by 2. Clear? So this is the answer, the probability. Is it clear? I hope it is clear. So I did the first two bits. It's up to you to solve the last second C and D. So this two will be your homework. Okay, C and D will be your homework. Please try to solve them. And I will see you in the next session. Thank you very much for watching.